Hi, my name is Sreekanth Kannepalli. I did get the honor of being mentioned multiple times by Kristen, and thanks for that. So I work in a group called Foundry 99, and this is a startup accelerator group inside Microsoft Research. Our responsibility has been, building a team with Kristen to push forward encryption technologies, AI technologies, and how we apply privacy in AI. So private AI has been one of our topics of interest for the past year and a half. So why are we interested in this? It's quite fascinating. I mean, you look at this world today, and there's always this there is this notion that we want to build AI-based services, and there are industries that want to collaborate. This internet has created this collaboration paradigm where everybody wants to bring data from multiple places and then use this for providing more innovative services, such as in finance, in health, in manufacturing. Christian presented part of this, but we look at situations where companies are not being able to collaborate. There is, if I look at finance, there is anti-money laundering, right? It's a big issue where financial institutions are not able to collaborate with each other to provide an optimal service. And this we see as lost opportunity. So we think that it's a $50 billion market opportunity for when we can provide more privacy-preserving services. The known barriers are pretty obvious, right? There are two very, very big barriers when you think of data sharing and collaboration, and this is privacy and security. And where it differs, I'm sure you all know where it differs, is that privacy is when you want to protect your customers' data, but you want to be privacy aware. You don't want to intrude into a customer or a business's work. Whereas the security is, if you're not able to handle the data properly, that you lose it and some other threats happen. So where we looked at is, for example, one of the ways is when consumers' privacy is violated through their health data. We have always seen, we are wary, right, that when we present our health data, and there was this example where recently when somebody was, when a company like 23andMe is taking your genome, your data, and then you don't know what they're doing with the data. They could be selling it. They could sell it to your insurance company, and then you probably end up paying more insurance. I don't know. So there is concern where a consumer is really worried about their own health data and how an organization might protect their own privacy. There is also an issue when consumer data is mishandled, right? Now this is an example where there were issues where an app that you were using, like Strava, inadvertently published a heat map of all runs that their users was doing. This is not intended, there was no malicious intent in this, but there was just mishandling. And what happened? That they ended up identifying military locations across the world, because there were these military people were also using Strava. And you suddenly, in the middle of a desert, you see this a heat map of people running around, like, hey, what is this? And there was curiosity around that spot. Now, this was just mishandling of the data, right? A weather app, Christian showed you a secure weather. There is a reason we built that app, because there was this weather app that was capturing users' location data and was now sharing this. This was not the intended use of a weather app, right? You want to use a weather app because all you want to do is get the weather of the particular location that you're in. And also, for example, companies as big as Google are always being challenged about the use of location data from their users, right? Now, but they do this because they want to provide personalized services. Finding a restaurant around you, finding a theater where you could go around you. Now, these are things that you're querying Google about, but then they have to store this location that belongs to you. So in essence, they can tell where you are actually going around. And this, then there is the security issues where, there is this, companies are holding your data as strictly and as safely as possible. But then there are there is malicious intent by hackers who want to actually access the data while it's being stored in the cloud, and being able to extract the data that could then be used for that they would use it for malicious intent. Now, there's huge ramifications for companies when such a breach happens, right? They lose trust from their users. They have financial losses that happens because of that. And eventually, there are some companies that have probably gone even bankrupt because of such data breaches happening. And why do we have to look through all of these, right? Like, the new digital revolution is about AI, and AI is data hungry, right? One of these articles is very interesting for us because it does question the basic premise of AI, saying that is AI the ultimate test for privacy? It's a kind of like a yin and yang problem where you look at it and say that I need data to build AI services, but then I don't want to access the data, because if I do, then I have to take care of privacy and security of the data. Now, how do I solve this problem? So what we see is a potential opportunity is that AI requires gathering and storing huge amounts of data, and then there are new collaboration models that have to be established for services to build. Imagine this. I mean, this goes back to the lot of health-related scenarios that Kristen mentioned. You want to do better cancer prediction. One of the best way to gather data is by asking every hospital that is actually getting, where radiologists are actually analyzing images, to contribute that back to a central repository. Now, this is nearly impossible given the regulations and stuff that exist today. But maybe with these new upcoming technologies, that landscape can be changed, and there could be new data collaboration paradigms. So the main challenges that we think are like, there are data management policies and regulations that basically eyes off. Even within Microsoft, we are eyes off when we look at Office data. We don't look at your data when we come to providing better services. Or there has to be a model where we trust third parties, right? This is a common pattern in financial services where they establish new third parties that say that, hey, Bank A and Bank B cannot collaborate with each other, so here's my data that I will share with a third party who is a trusted party, and then we hold our data commonly in an escrow. There are these issues. If you take typical offerings in cloud-based services, where there are a lot of implementations of encryption. While data is at rest, you could encrypt all your data and store it in rest. But when you have to process it, you obviously have to decrypt it today until we get homomorphic encryption completely into the cloud, right? Because that is a problem. When you decrypt the data, it is vulnerable. And then you would put barriers around it that people cannot access the data, but still it has been decrypted. And there's a huge aversion to market entry because people are just not able, there is trouble in putting a foot forward when you see issues such as privacy and security. So in summary, what we have learned is that regulations have become policies, right? In financial services, there are a huge number of policies that restrict companies to collaborate with each other. We have seen that when companies, and this is between companies, large companies, right? When there is ease of breaking trust, when there is misuse of data. It's not only between companies, it's also between consumers and the companies, right? Like the example that I said, you use a weather app because you want to just get the weather, but then if that is being used to track your location and shared with legal agencies, the trust is totally broken. And you always hope that your data is being handled properly, right? How many of you trust that your financial institution is handling your information when you apply for a loan as best as it can? You do have a trust with them, but then the trust is broken the instant that your data is breached, right? There were instances recently of large financial institutions storing username and passwords in a cloud-based Dropbox file share, maybe, right? This has happened. And these are the instances when data breaches happen, right? And So, learning from all of this, we at Microsoft have been focused on a lot of scenarios, right? And, and these are examples. These are examples where you could possibly think of how this can be applied for somebody as big as Microsoft. With Office, for example, our motto is like empower every customer with new AI-based services while protecting their privacy and data, right? You think of the new services that Office is building into your platform, which includes like the PowerPoint designer. It's a fantastic feature, right? And how do we protect the customer's privacy while doing so? Or you could think of it as Azure-based cloud offerings, where we empower our developers to provide privacy-preserving cloud-based services. You could think of this as cloud-based data sharing services, where we provide Azure being a platform as a service, we empower other developers to build on top of that. Or you empower existing product offerings, and this could be like SQL and Spark and so on, where we empower it by providing models that leverage homomorphic encryption to ensure that the data that is used that these services use are encrypted at all times. We could also think of vertical offerings like, and we can empower businesses to offer solutions such as, cancer prediction or anti-money laundering or know your customer. And we have seen that homomorphic encryption applies really well to some of these scenarios. It's got a duplicate. So Kristen did talk about that, and one of the reasons I brought this back is that I really wanted to say how a company can think of providing solutions leveraging technologies like homomorphic encryption, right? Companies have been taught and told how to build applications in a very common way, which is like, you store the data unencrypted in the cloud, then you do some processing and so on. But Azure Run is an open source example that you can take a look at how you can change the paradigm of a commercially available application where the organization takes responsibility of storing data only in an encrypted form, but still being able to provide the same service that they were offering when data was not being encrypted. And so on. So there are plenty of ways to think, or models to think about how homomorphic encryption can be applied in the real world, right? You could think of doing eyes-off training, which means that you always have data encrypted and you do training on it. You could think of enabling really secure data sharing, where you have two parties that only want to share bits of data between each other, where then this goes back to the private set intersection example and the kind of secure weather example that we showed, right? You could also think of it as outsourced storage and compute, which ties back to the whole thing around prediction or analytics in the cloud when data is always encrypted. Or you could think of building multimodal data sets where you acquire the data by by using a federated model across multiple companies and so on, and you acquire the data, which goes back to the cancer prediction. You acquire multiple data sets, encrypted manner, and then do some analytics or training on top of that. And yeah, enjoy the boot camp, and we're here to talk to you. All right, thanks.